Hi folks, this is Cheryl. We're trying something new today between the Rambly kind of live game thing where you can go and chat to other people, walk around and watch it with other people. So give me a moment.
Yeah, we can hear you twice, Cheryl. There is some echo.
Yeah, we can hear you twice.
Okay. Let me switch to the next one and tell me, are you still hearing an echo?
Yeah, it's still an echo, Cheryl.
Okay, give me a moment. Let me figure this out. I said, this is something new. So thanks for being patient.
Oh, I think it's when you have the app open, you know, the app you gave us.
Oh, I think
Yeah, just make sure you close the, you hear one or the other. You hear either the, if you're on Zoom, you hear Zoom. If you're on something else, you hear something else. On Zoom, you hear Zoom. If you hear.
Yeah, that's fine. Basically, you can remove the sound on the.
Yeah, that's fine.
One.
You can remove the sound on the.
Okay, I'm going to assume everybody knows, everybody's kind of on top of it now and everyone's figured out what things they need to keep muted and what things are open. So hi, everyone. Really great to see you. Thank you so much for joining as usual. I'm going to quickly run through a welcome and then we're going to go into our usual lineup of 3 speakers tonight. Just want to say Cloud Native London is a strong, open, diverse developer community for the cloud native platform and technologies, usually in London, but of course now we're virtual, so everywhere from London, UK and beyond. My name's Cheryl. You can find me on Twitter at @OiCheryl, and I'm the VP of Ecosystem at the Cloud Native Computing Foundation. So if you might be joining on YouTube, you might be joining on Twitch. We also have a new Rambly where you can come and hang out, meet the other attendees and the speakers and chat to them. And as a result, we're also going to use a service called Poll Everywhere to collect your questions for all of the speakers. So the whole point of that is to find out a little bit about you. And that's what we're going to do right now. So please go to this link. Just on your phone, on your laptop, you don't need to download anything. Just go to oicheryl.com/p and you'll come to this screen where you can put in your name and you can just tell us a little bit about where you are, what you're doing. Okay, so first question, is this your first time at Cloud Native London? You should have 2 possible answers. You should have yes or no. So again, if you missed that link, oicheryl.com/p, you can also go to this pollev.com/CherylHung link. Cool. I think people are starting to figure this out now. Nice. Looks like we've got mostly people who have joined before. Handful of new people. If you're new, then welcome. Really happy that you've joined us. Okay, I'll just give it 1 more second. Okay, yeah, people are still figuring this out. Awesome. Okay, so when about 90% returning people, which I love to see, and about 10% new people. So welcome everybody. Next question. We can move there. Here you go. Where are you right now? So just choose wherever you are, whatever country you're in. So seeing quite a few UK people, someone joining from Portugal. It's awesome. Someone joining from Spain as well. Very cool. Let's leave a couple, 5 more seconds, because there's a little bit of delay as well between Zoom and YouTube. So I want to make sure everyone gets a chance to tell us where they are. Oh, we got a second person coming from Spain. Super cool. All right, nice job. Let's keep going. Dun, dun, dun. All right, what's your job title? Just so we can find out a little bit about you. Just pick the closest to whatever your job title is now. It doesn't have to be exact. Architect, application developer, backend developer, engineering manager, SRE/DevOps, security engineer, or anything else. All right, looks like architect is steaming ahead. Cool, and I think this is pretty typical actually for this crowd. We're mostly a mixture of architects and SRE folks. Cool. A few people coming in for other as well. All right, nice. Okay, now I've asked our 3 speakers tonight to ask some questions about you. So we're going to go over to the first question now, and I'm going to ask our speakers as well to just comment on what they were expecting and whether the results lined up with what they wanted. So we've got Denis first, Xavier, and Peter, and I'd like to welcome all 3 of those. And this first question, what is the popular proxy that is part of the CNCF? So your choices are Ingress, Envoy, Nginx, or all of the above. So let's check who asked this question.
Yeah, it's me.
Denis. What were you expecting?
Yeah, I mean, it's good. So I don't have to ask in the talk if people are aware of Envoy. It looks like. That's good. I put the all of the above because it's kind of, when you put that, most of the people, they feel that is the right answer, whatever the question is. So.
It seems people are pretty confident that Envoy is the most popular proxy part of the CNCF. Yeah, not even any results for other ones. But yeah, Envoy is pretty well known. Cool. Let's go to the next question. And I think this is interesting. What is the right way to template manifests for Kubernetes? And the options you've got are Helm as is, Customize as is, Capitan as is, something variable like Helm, just not Helm, something overlay based like Customize, just not Customize, programmatically serializing objects to YAML, or programmatically deploying it to a cluster. So let's wait and give a few moments for people again to think about this question and ask it. Peter or Xavier, was this one of your questions?
Yeah, that's my question. I'd rather not say anything until the results are in to not skew it.
Interesting. Okay. Oh, some people voting for programmatically deploying to a cluster, and some people voting for customize. Very equal, actually, so far. Well, yeah, again, maybe not to bias this, but yeah, okay. I was expecting someone to vote for Helm. Just would have surprised me a little bit. So yeah, is this what you expected?
No, but it's what I hoped.
Oh, interesting.
Yeah.
Okay.
Yeah, it's around the diversity of templating options, but I think it'll make a lot of sense when I start talking.
Okay. Well, I'm very curious to find out what you mean by this is what you hoped. And actually, yeah, there is quite a good variety, good mix of options here. Nice job. Thank you, everybody, for answering this one. We're going to go to our final question for this evening. So, dun, dun, dun. Okay, big general question. What are your biggest obstacles for cloud adoption? So choices are DevSecOps process, tooling, compliance, security, and resources. And Peter, I guess this was your question then. So do you want to talk about maybe some of, what do you mean by some of these answers?
Yeah, I mean, I think there are a couple of key elements in moving to the cloud. And honestly, this is roughly the kind of answer that I expected. And I mean, obviously the CNCF is doing some really good work around tooling. And all the other things that aren't tooling are really, really difficult.
I'm curious actually what you mean the difference between security and DevSecOps. What do you...
DevSecOps is more the human process that you put around security, whereas security, I think itself in isolation is just the sort of areas that you can cover with monitoring. In a lot of companies, these two are actually disjoint. They are not necessarily involving security in the DevOps process. And there's a different separate team that deals with that.
And resources, which has come out the winner.
I mean, I generally kept that vague because everybody understands different things under resources. I really dislike using resources for lack of human power, but obviously that's an aspect. Sort of funds or generally just available time because of all the feature pressure and regular firefighting that's going on.
Fair enough, and it does seem like most people have problems or have difficulties with getting enough resources. Awesome. I just want to say thank you, everybody, for following along and submitting your answers. This is really, really useful and really interesting to see the results. Right, a couple more slides to go. So I want to say thank you for tonight's sponsors because they are the ones who kind of make sure this can keep running. Lizzie, would you like to introduce Technovo?
Hi, yes, I would love to. Hi, everyone. I hope you're all well. I'm Lizzie and I'm marketing manager at Technovo. We're a challenger digital consultancy providing expert partnership and growth without creating dependencies on or disrupting culture. Community is truly at the heart of everything that we do, which is why we're really proud to sponsor Cloud Native London. There are two ways you can find out more about us. I realize this is very brief. You can either message me on Rambly, or you can follow our LinkedIn page where we post our latest updates, our blog posts, including our digital advent calendar, which we launched yesterday. You can keep up with that. To find us on LinkedIn, you can just search Technovo and make sure it's Technovo with a K, not a H. I also want to tell you about one of our community initiatives, Tech Camp. You might have heard of it already, but Tech Camp was also proudly partnered with Cloud Native London. And the idea behind the initiative is simple. We just want to ensure that tech events are open, accessible, and fun for everyone who wants to take part. Given the times that we're in, obviously this community is more important now more than ever, and our Slack channel is always busy with where like-minded devs can come together, discover the latest virtual events happening, and discuss what they've learned. You can find out more about Tech Camp at tech.camp, and you can also sign up there for our Slack channels. I look forward to seeing you all joining the group soon. And that's all from me. Back to Cheryl.
Sweet, thank you, Lizzie. And then I would like to welcome Ashley to say a minute for Palo Alto Networks.
Thank you, Cheryl. Yes, Palo Alto Networks, we sponsor CNCF London because we're a big cybersecurity company, but we've actually gone and seen the light, and we are now doing an awful lot of cloud native stuff, both internally and also wanting to be more involved in the community. So that's why we sponsor. It also lets us say that if you do enjoy things that are cloud native, Kubernetes, all that kind of stuff, and you enjoy security as well, then please get in touch because we are hiring. And that is it. I am just going to do a very, very short one.
Nice. Thank you so much, Ashley. And I don't think Humio sent anybody this evening, but just want to say thank you to all of you. If you're interested in speaking or sponsoring, we're now booked pretty much a year ahead. So you can go to this link and you can request to speak for events that are coming up end of next year. You can also sponsor us and promote your own events through that. I'm going to quickly take a selfie, which today means I'm just going to take a screenshot of Rambly. So everyone who's in Rambly, hang out for a moment. Okay. Okay, actually, I'm going to check. Everyone face front. Okay, everyone move down so you're facing front. So your face is facing front.
But this is funny.
Nice. Okay, done. Thank you, everybody. And basically that's it. We're going to go to Denis now. So Denis, please, I'm going to hand over to you.
Thank you very much. So let me share my screen. Can you see it?
Yep.
Good, good. So thanks everyone. So I am Denis Jannot, Director of Sales Engineering at solo.io in EMEA. And you have some, my contact details there. So feel free to reach to me after the talk. I'll be happy to discuss. So I'm going to speak about, like you see the title, the challenges about exposing and connecting microservices. So basically it will be like a two-part discussion. One is about how do I expose my apps? How do I secure the edge, let's say? And then how do I handle service-to-service communications? And I'll start obviously with things that are, natural for everyone here. This trend going from monolithic to microservices, and I think everyone agree as well that the way you deploy these microservices today are on Kubernetes. But then when you start to use Kubernetes, one of the first thing you need to do is to expose your apps, because most of the time when you deploy an application, then you want to access it from the outside world. And naturally, what you do at the beginning is that you use like an Ingress controller, like HA proxy or traffic or any other. And you start to expose your apps that way, and you get it working, and you get like basic like TLS and basic routing and things like that. But very quickly you find out that you need to do much more in terms of security, but also you want to be able to expose some apps that are on Kubernetes, but some others that are not. And we see, for example, as well today, this new trend where instead of implementing all the authentication and authorization on your microservices, and you have to repeat yourself all the time, developing again this integration, it makes a lot more sense if you can do that with an API gateway, so that you delegate all that part at this level, and you can focus on developing your microservices without having to care about these authentication and authorization. And obviously then a lot of questions arise, like you need to be able to authenticate people, but then you still need to be able to have a way to tell your backend or your microservices who has authenticated. So you need, for example, you authenticate with a OAuth provider. This OAuth provider give you like a JOT token. And from this Joe token, you want to extract some info from a claim, and you want to add a new header so that the backend service that received the call knows who has authenticated. So this kind of feature that you expect from an API gateway, but as I said, you still have generally some application running in VMs, for example. So you want to also be able to handle this legacy environment. At the same time, you can have other teams that start to experiment with function as a service, I don't know, using Lambda or things like that. So basically, very quickly, you find out that you need a powerful API gateway that cover all of these use cases. And at Solo.io, we have this gateway called Gloo Edge. In the past, we were just calling it Gloo, but we kind of rebranded our different projects under the Gloo umbrella. And the one for the API gateway, we call it now Gloo Edge. And Gloo Edge is this API gateway that you deploy on Kubernetes and that allows you to expose all your apps running on Kubernetes, but also your apps running on legacy environment and so on, and giving you the ability to transform your request and so on. And this is Gloo. Basically, Gloo Edge is just like a control plane for Envoy. And as you all know, Envoy is like a CNCF project that is quite popular, especially when we speak about service mesh, and I will go through that in a minute. And the idea of Gloo Edge is that it comes with Envoy for the data plane, but we also extended Envoy with additional filters so that you can perform like external authentication or rate limiting or. Oh, sorry, I cannot. Can you hear me?
Oh, don't worry.
Okay, it's okay. So you can use basically Gloo for all of these different use cases, and we have these filters sometimes that reach to other components, and some others are just like altering the request when it comes. So for example, we have one that do like web application firewalling based on mod security. We can do like advanced transformations and so on. So that's what Gloo Edge is in a nutshell, a control plane for Envoy, and it comes as well with additional filters and capabilities so that you can cover most of the use cases I discussed about before. We have like an open source version where you can do most of the routing and transformation things, and an enterprise version that focuses more on security as kind of usual. It's quite common to have this distinction. And with the enterprise version, you get additional capabilities like external authentication with OAuth, basically like using Joe tokens, using like authorization. You can use that open policy agent that we have embedded there, and you get also like a developer portal. So the way we see people using the gateway in general is that when they want to expose their web applications, they want to protect this application with OAuth, and as a user you authenticate, and then you get access to this web UI. And as I said, we can pass all the information about the user through headers and so on. And then the other use case is that you want to expose APIs. And generally, when you want to expose APIs, you want to protect them with API keys or Joe tokens, but you also want like your end users to be able to browse your APIs and be able to try them out and so on. And that's why we have this developer portal. And another thing that comes quite quickly when you start to grow, that you have multiple clusters, and you start to deploy Gloo Edge in multiple different environments. And at some point, it becomes quite difficult to manage everything and to manage all the policies to describe the way you want all the routing to happen. So that's why we have also this Gloo Federation components that allows you to simplify the management of multiple clusters and all the policies that you have on these different clusters. but it also allows you to manage this kind of failover. So let's say you have requests coming on one cluster and you configure everything in Gloo Edge so that the request should be sent to this pod here. If this pod becomes unavailable, you can create a rule so that automatically it will be redirected to another cluster where you also have Gloo Edge running. And I'm going to do a quick demo of that so that you can have an idea about how it works. And then I'm going to go back to some slides and cover the rest of the presentation. So here what I have in this environment, I have like a VM where I have three kind clusters running. One where I have, let's call it like a management cluster. And the two others are like clusters where I have Gloo Edge running. And the idea in this environment is that I deploy the same app on the two Kubernetes clusters here. And one will return blue and the other one will return green. So that we'll be able to, I will be able to show you that if I scale down the corresponding deployment here, I am automatically redirected on the other cluster. So we have a workshop we do where we cover all of these things in details. And I'll speak about the workshops quickly at the end. But here, I will be quite quick and I would just like show you a few things. So the first thing I want to show you here is that this ability we have to create like federated resources, a little bit like what you see in KubeFed, so that you don't have to define the policies for all the cluster one by one, but you can create these federated objects and that will be applied in the cluster you want to target. And then, as I just described before, you have this failover schema so that you can say, for this service, I want to have like a failover group so that if this service becomes available, I want automatically to redirect to this other service in another cluster. And just to demonstrate that, I am going to run this command here, which is like just a curl that will send a request on the first cluster. And basically, this is just like the external IP of my service. So if I just like do a copy and paste here, you will see that if I do like a get SVC, that's here the IP of my service on this cluster. And I have this blue-green service that returns blue on this cluster. So if now I try to scale down this to 0, I'll get after probably 20 seconds or something like that, this pod will become unavailable here locally. And if I send the same request, then I should get green if I am correctly redirected to the other cluster. So while it's terminating here, I can show you that there is also like a UI that comes with it so that you can see the different instances of Gloo you have, the different deployments, and can go through the different objects. Everything we do in Gloo, we configure everything through CRDs. So you can see these are all Kubernetes objects. So you can configure everything, using a GitOps approach. It's quite easy. And you see here, there is a failover configured for this service, as you can see there. So now like the pod should be terminated. And if I try to reach it, oops, then I get green pod. So that means that I'm still having access to my service, but then this time it goes to the other cluster. And if I would change it again to 1, then it will come back. And as soon as it will be back, it will start to send a request to the local pod again. So again, that was really quick. I could speak about just Gloo Edge for like hours, and we don't have a lot of time. So I'm going to switch to the second part, which is like now that you have an API gateway to secure the edge, then generally the next step is how do I secure or how do I enhance, let's say, service-to-service communications. And here you want to do a lot of things, how you like how you manage the identity of the different workloads so that they can know and validate where the communication are coming from. How do you manage encryption between when this communication occur between these different services? How do you, when you want to encrypt all the communication, then you need certificates. How you manage the certificates? How you do all the rotation of these certificates? How you manage traffic? You define, like canary deployment and all these things. How you manage health checks, or like a lot of different requirements. And if you just take like what you have out of the box on Kubernetes, it's quite limited, right? If you want to encrypt your communication between your services, it has to happen at the application level. The Kubernetes service can help you a little bit in traffic management and health check, but then if you want to cover the rest, getting some telemetry information and so on, then you need to use third-party software. One way people have managed service communication in the past was through an API gateway as well, so that you let the API gateway providing a lot of these different capabilities, but the way you manage traffic and getting some telemetry information and so on. But still, it doesn't solve this encryption problem, and very quickly it becomes a bottleneck. So that's definitely not really the way to go. Oh, let me just go to presenter mode as well. I always forget to go back there. So that's why, and that's a drawing I just added here, but basically what we see today is really people want to adopt service mesh for that, so that they can manage encryption outside of their app. They can get a lot of telemetry information, and they have like this notion of having like a control plane on one side where they define all their policies and manage the identity and all the things, and then a data plane where everything is enforced. And you see here, I put like the Envoy icon because definitely most of the service mesh solution out there are based on Envoy, and I'll speak about why in a moment. And here I just quickly added before the talk this VM here, because we really start to see that becoming like a common use case. So as soon as you start to adopt your service mesh, you have all this nice capability to encrypt the communication between your services and to get a lot of insight about what's going on. Very quickly, you tell yourself like, okay, but it would be even better if I could also have my legacy workloads part of my mesh. And that's really something we see more and more. So why Envoy? Obviously, many reasons. It's really powerful proxy, provide very high performance. It has been adopted by many companies, so it's proven at scale. And one of the reasons it's so popular for service mesh, I think, is because it has been really created to be driven by API from the ground up. That means that it's not like legacy proxies where you were putting your configuration file beside it, and this file was written was read to determine how to route all the different requests and so on. Here it's really driven by an API. It has been designed to be driven by a control plane, basically. So it really fits well for these service mesh use cases. And as I said before, you start to adopt service mesh, and very quickly you want to also have your legacy workloads part of the mesh, so having your VMs, your application running on VMs, part of the mesh. But also what we see very quickly coming is you want to have this multi-cluster mesh. So you want basically to have services running in multiple clusters or even multiple clouds, being able to communicate together, either for failover purpose or just for other cases where you need to have these different services interacting together. So at Solo, we launched this project called Gloo Mesh, which is it's not another mesh, because we've seen a lot of mesh there, but it's really like a way to simplify multi-cluster mesh, let's say. And we see that, like I said before, this needs where people want to have this cross-cluster communication, And when they start to think about it, they find out that there are many different challenges. So one challenge, for example, is how do I ensure that one service here can validate the identity of another service in another cluster. For that, you need to federate the identity. So you need to have like a common root certificate. So you need to put that in place. And then when you have that in place, if you want to configure this kind of traffic, you need to create multiple different configurations. So here we take the example with Istio, which is, I think, currently the most popular service mesh out there. And you see that if you want that to happen, you will need to create multiple objects. For example, you will need to create like a virtual service where you would define how you want to split the different communications. So let's say if I want to have like a percentage of my requests going locally on one version, another percentage going locally on another version, and another percentage going on another cluster, then you need to define that in a virtual service, but then you need to create destination rule for all the different subsets that correspond to your different versions. Then you need to tell it how to go through, how to reach this remote URL here, so that you need to give it like the IP of the gateway of the other cluster. And then on the other cluster, you also need to create some other objects. So it's quite complex, and it's just for two services communicating together. So what we do with Gloo Mesh is that we create some abstractions that are global. So this Gloo Mesh is not like with Istio where you have like each cluster is independent. Here with Gloo Mesh, we create these global objects where you can very easily describe using CRD, you can describe what you want to achieve. So I want this percentage of request in this cluster on this version and so on. And this is translated in Istio objects. And it's not only Istio, we started with Istio because it's the most popular one, but we are already working on the app mesh integration, and we will continue with OSM as well. But the idea is really to create this abstraction for multi-cluster mesh. So that's an example here, and I'm going to do a quick demo of that, but then I'm going to speak about a few other nice things that you can do with it. So very similar setup to what I described before, but here I have Gloo Mesh in my management cluster, and I have Istio running on two different clusters. So we deploy Istio. Again, we have a workshop where we cover all these things in details, but we deploy Istio with a different trust domain so that each service running on each cluster has its unique identity across all the clusters. And then to be able to communicate together, by default, all the services are allowed to communicate with all the other services. But what we do is we have this capability to just disable all the access. So when we create what we call a virtual mesh that we use to federate the identity of these different clusters, we have this option where we can enable global access policy. That means that by default, one service cannot communicate with anyone else. And then we have this abstraction we call an access policy that allows you to define which service can talk to which other service, and you define on which cluster. So you can really have like a fine-grained control about all the communication that you want to allow globally. And as soon as you have these access policies in place, then you can start to define some rules to allow cross-cluster communication, like I described before. This was the example I had in my slide. And just before I apply that, I'll show you what is the current status. So the current status is that all my requests go to this cluster, and I have this book info app that you probably already know if you played a little bit with Istio. And in this cluster, I only deploy the V1 and V2 version of this microservice, while here I have the V3. And if I look here, when you have the V1, you get no stars here. If I refresh, I get black stars, which is the V2, and I will never get V3 because currently all my requests goes locally. But if I apply the CRD that I was speaking about just before, this traffic policy, where I say I want to send 75% of my request on V3 on the other cluster, then if I apply this CRD there and I refresh my page, I should start to see most of the requests going through V3. You see that are the red stars. So really simply with one CRD, I was able to define this cross-cluster communication. And then I get this nice UI that shows me like what is currently configured. I have one virtual mesh with two different Istio clusters here, and I can go and see the details about the different workloads that are running there, and I can see the policies I have created. So here, that was my simple policy. And you remember in the policy, I was just describing what is the service account of, or what is the workload I want to target and how I want to spread my request. And you see it translated here. But the same for the security policies. So here I have a policy where I want to allow the reviews microservice to run to communicate with the rating microservice. And you see the UI shows you what are the current workloads in your cluster that are targeted by this policy. So very quickly you can see if you made a mistake or if the policy you created is impacting some other workload that you didn't want to impact. So I won't go through that in more details, but you have multiple other things you can do with it. We did this traffic policy like that, but you can also have failover policy so that the traffic is redirected only if it's not available and so on. I spoke already about the Gloo portal that allows you to expose your APIs to the outside world. That works for both Gloo Edge or for Istio. So you don't need Gloo Edge to have the portal running. You can decide if you want to use it with Gloo Edge or if you want to use it with the Istio Ingress gateway. I won't go through that in details. I really want to use like the few minutes that remains to talk about the future of Envoy. And I'm sure you already heard about WebAssembly. So if you remember correctly, previously in my talk, I was speaking about the way Envoy works with all these Envoy filters. And when we package Gloo, we create these filters in C++, and we have to compile everything together so that you get all these nice features. But now that people are adopting more and more Envoy here for the edge, but also for service-to-service communication, a lot of time people comes with very specific use cases. I want, when this request happens, I want to do something very specific. I don't know. I want to call another service and send an API request and get some information and enrich my request with a new header based on what I got, for example. So a lot of use cases like that. But because it was very difficult to develop these filters and you had to compile them all together with Envoy, it was very difficult to extend it. But with WebAssembly, you can now basically create your own filters with different languages using SDKs. So you can already do that with AssemblyScript, with Rust, with TinyGo. And now you can deploy, so you package them in as WebAssembly, and then you can deploy them on a running Envoy instance. So it's a lot better. You know, you don't need to compile that together, and you don't even need to restart Envoy so that this filter is applied. And to make that adoption easier, we created this WebAssembly hub, which is very similar to the Docker hub, and we created some tooling around it. That's mainly this CLI called WASMI. So you take your SDK you want to use, you write your filter with this SDK, and you do a WASMI build, and I will create your WebAssembly out of it. Then you will do a WASMI tag like you will do a Docker tag. And then you do a WASMI push, so that push that to the WebAssembly hub. And then you do WebAssembly WASMI deploy, and you say, okay, I want to deploy it on Gloo Edge, or I want to deploy it on Istio. and I want to deploy it on Istio, on all the services that have this label, for example. So really like all the tooling to make the adoption of WebAssembly easy. WebAssembly is not really ready for prime time right now, but we are close to it. So it's now part of Envoy upstream, and a lot of work is happening to make it like production ready. So I think it's really good that you start to explore it, and I'm pretty confident that in a few months you'll be able to really use that in production. So just before I finish, we have workshops we do quite often. If you want to have hands-on experience on either Gloo Edge, on Gloo Mesh, and all these things, really feel free to just go in our website solo.io, and you'll see here we have like the resources and events, and you can register there. We also do a lot of blog posts on Envoy, on Mesh, on many different topics that I'm sure you would enjoy. And we also have like a lot of videos in our YouTube channel, and people really like them generally because some are on our product, but a lot of them really are on Envoy itself or some technologies like OPA and things like that. So I really encourage you to take a look and see if you find anything interesting. So I think I'm just on time. Really want to thank you, Cheryl, for inviting me to talk here, and hopefully we'll have other opportunity to meet together, and this time in real face-to-face, not through Zoom.
No, thank you so much, Dennis. That was fantastic. Really appreciate you sharing everything with our audience today. Unfortunately, we are pretty much out of time, so I can't stop for questions. But I would like to introduce our second speaker for the evening, who is Xavier. Xavier.
Hello.
You ready? I'm going to hand over to you.
Yep. Again, there are no slides, so.
Awesome. I love it. Go on.
All right, cool. Hello, so thank you so much for having me here. I'm Xavier. My company is Nectar. Well, Nectar Cloud Software. We're a pre-seed out of EF, which is an accelerator here in London. I have a lot to cover, so I'm going to go really fast, so I'm sorry for that. And this is our first ever public reveal of any kind, so make of that what you will. So the structure is going to be very traditional. I'm going to start with the why, and then I'm actually going to mix the how and the what because of time constraints. And yeah, so the rest is just going to be a demo, basically an SDK overview, because Nectar is mostly an SDK. Okay, so why do we need to get better at sharing Kubernetes apps? So from users' point of views, today we have Helm, which I love. You install something new from Helm, get a total dopamine rush, right? Like something new is in your cluster. You get to see it open for the first time, and the data is yours. But that's on day one, and it's very exciting. But what happens on day two when you start, having adult conversations with your boss and other engineers about how feasible is this to, have this in the org? Kind of like I want a puppy, but then your dad tells you, oh well, you have to take care of it, and it's like, oh well, maybe I'll just get a Game Boy. And that's kind of the feeling today that I have with Helm. Like it's great for trying things out, but if you want to seriously deploy something in an org, it's like SaaS often wins out. So it's the operational knowledge bottleneck that makes the difference over here. That's from the user side. From the vendor side, just very superficially, like you're deploying on Helm, like where's my data? Like where's the telemetry? How many people are installing this? Is this breaking? Are those CRDs that I broke my back working for, even seeing the light of day? Like what are the patterns essentially? And then there's the problem of like all the things that are not declarative on Kubernetes. You see a bunch of really great tools like Istio-CTL, for instance. Like the vendor will tell you like, oh, get our command line tools so that we can do all the other stuff. And there's, like Kubernetes is declarative, but sometimes that you just have to face the reality. There's stuff that needs to get done imperatively. And so typically that's just, like going 6 feet deep in READMEs and stuff like that. not to mention, like a lot of things on Helm Hub today have like 20, 30, 50, 60 manifest variables, which if you didn't understand them, like, good luck talking to your CIO. And then, yeah, so third thing for vendors is we tend to forget nowadays because, it's SaaS everywhere, but on-prem and virtual private clouds are still a $100 billion a year industry. And a lot of companies actually kind of get that 80-20 distribution of revenue, where 80% of the revenue comes from, like a small pool of high-paying enterprise clients who need on-prem. And I know on-prem is dying, but like virtual private clouds are not. And when I was a CTO at Hinge Health in the US, sorry, that was a very big culture shock to me, because I'm, like an entitled millennial, like cloud, and then people are like, no. So that's something you have to deal with. And then kind of on the holistically, or however you want to say it, like personal note, like, Kubernetes is the most exciting thing, and there's clearly so much enthusiasm. We're all here, and I just find that there's an awkwardly long path to market or to distribution. Like if you have some clever thing that you want to put that's Kubernetes native compatible, like how do you distribute it, and how do you get paid fast? Because that's that's in this kind of industry, it should be like, you make, you get. So that's the why we need an app store. Yeah, and I'll acknowledge that there are competitors in this space, but they're kind of catering to the traditional one-to-one, I know your name on-premise model, where it's kind of like this CTO talks. It's not of my generation, and that's So before I get into the product, which will be the rest of this presentation, I just want to talk about architecture really quick. Two very important things, because I will jump off a bridge if you guys end up feeling like this is basically a UI for Helm, because it's not. There's a lot more to it. So to my poll question, in asking you what how you do templating, is it programmatic, is it a mixture of things, overlays, variable based, whatever. Something that kind of shocked me when I started Kubernetes was in defining Helm, I actually found that it had two distinct definitions. It's both a templating engine and a social package manager, I guess you could call it. Package management, distribution, all in, Go-based templating, I don't know. And as the poll, it seems to be a pretty common opinion. So the first architectural keystone in Nectar is we completely decouple templating from distribution. When you think about it, templating is very simple transactionally. Like the computation can be complex because you've got all these variables and all these crazy things, but the actual transaction is I give you variables, you give me a template that, a manifest that represents resources for Kubernetes for application. And so with Nectar, as a vendor, as a publisher, you have two ways to give us your templates. You have to have an API that's available on demand, where we can send you variables and you give us back YAML, or a Docker image that does the exact same thing. So it's a super simple protocol, which I'm going to show you in a second. But effectively what this means, and so yes, you need to Dockerize your templating computation, but we have templates for that. Templates and templates. But it's very simple. It's like 3 lines of Docker, and you can use any templating engine you want. You can use Pulumi and like native libraries in various languages, as long as you can output to JSON or YAML. So it's kind of democratizing that. So that's the first thing. Second thing is about keeping clusters pure. So it seems that a lot of the configuration layer for complex applications nowadays is actually expressed in CRDs, when all you're doing is trying to simplify the operation for the end user. So the position that we take is that you should whatever you put inside a cluster should have as little permanent effect as possible, right? So try to avoid pollution at all costs. And so something that you'll notice when I'm showing the SDK is that we'll be doing a lot of YAML-y stuff that looks almost identical to Kubernetes, but 100% of the functionality that's inside Nectar is compacted into one deployment. It helps you, it does all the things that we'll see. But there is not a single custom resource definition. There is not, we're not spraying the place with admission controllers. or anything like that. It's, you put Nectar in, it's not a platform, it's not a, it's a deployment, and it helps you do things when you need it. So that's the second kind of principle. So I'm going to share my screen now, and I'm going to show you what it's like, an end-to-end journey deploying with Nectar. Unfortunately, I can't show you like monetization and getting paid and stuff, because that's not ready, but that's, it's just like Stripe, like 2020, just get paid in Stripe. So share my screen. I'm gonna do this. Let me know if you guys have problems, because it's been kind of wonky. Yep. Okay. So we are going to go to the vendor website. This is accessible right now. The security is really crap, so please don't break it. But you can. So we're going to start by publishing an app. We're going to call it, let's call it Dice Cream, because I've been doing a lot of ice cream stuff. Choosing an image. I just have a ice cone prepared. Oops. So I'm going to set that in the URL. Sorry, the image. So we're going to set the default namespace to Dice Cream, although users can modify it, whatever. Sorry. Go. And then this is the stuff I was talking about. So instead of like uploading a bunch of YAMLs or whatever, we're going to give it a pointer. So this is so TAM means Templatable Application Manifest. That's the acronym that I came up with. And so there's different ways to do it. It can be a local executable that ships in your Wiz, but we're not going to do that. You can have your own manifest server, but we're not going to do that. You can have a cluster image, which it's actually what we started with, but we found out that there's like a 10-second delay when you're starting a new container in Kubernetes, which really breaks the experience. So we're going to go with manifest server. And the TAM, so the thing, so you recognize this. This is a Helm chart. Nothing innocuous, totally useful, totally recognizable. But you can also use other things. So this is Kirby. This is actually a templating engine that I created myself, which I'll be showing to you guys shortly. It's based in Ruby. But the point is, it's all about variety, right? Like you can just, it's your YAML, you do whatever you want, as long as you can Dockerize it. So I'll show you the Helm version. And this is what Dockerizing a templatable application manifest looks like. You just base from this Helm to API. And then it's going to run TAM server, which is a binary from a Python app or a Flask app that just looks for Helm in this case and forwards commands from the URL and from the body of the request to Helm. So I already uploaded it. Actually, this is 101. Just show you there's nothing weird going on. So we're just going to do publish. I don't know if you guys can see that part of the screen. It's kind of small. Yeah, there you go. So really nothing sexy going on here, just uploading a Docker image. And we're going to take that Docker image's name and we're going to paste it here. So if you're curious, TAMC stands for Templatable Application Manifest Server Image. So Nectar Manifest Server, correct. And then this is our Wiz, which will be the bulk of the conversation after, but I'll just, oh, sorry. But I'll just do this for now. So the Wiz is kind of your control layer, and that's also an image that we're going to inject in your cluster. So I know this makes little sense now, but it will soon. And we're just, doing this. This is correct. So application wizard, ice cream Wiz, ice cream TAMZ, let's go. Permissions. So if you ever get this feeling that you have no idea what's going on when you're installing something with Helm, it's because you don't. So with this, you upload a file, which I forgot to show you, but it's just standard RBAC. And these are the permissions for the wizard, and they're displayed to you over here in a friendly way, but the user will see that too. And it's just, you recognize the stuff. It's just resources and verbs. But it's static, and it's like on the website. And once you commit to that, you can't go back. Distribution channels, available on any app store. You can have, beta, alpha, Europe, Asia, whatever. And then really cool is baseline variables. So Nectar assumes that your templating engine is completely variable based. So you can say like white label dot whatever, like my big client, and you can later associate these with clients or with plans. So yeah, you can have many of them, but we're not going to do that. And then actual plans, which you all know what that means: price, monthly, billing, whatever. But that's actually not working. So it's just gonna so go to the dashboard. No graphs. It's not ready because we haven't deployed our first version, so we're gonna do that right now. So click that button. Choose the application, Dice Cream. We're just going to create 1.0.0. So this is a manifest release. So this is referring to the templating engine. Yep, going to go create that, and then we're going to make a second one for the wizard. They're exactly two components to every Nectar application. It's the pointer to your templating engine, and then the wizard. And we're not going to have any notes. And by the way, normally you do this from the CLI, but I don't know. I think it's just easier if we do it here. So wiz release, blah, blah, blah. Let's go. And then in the servers, so you don't need to do this, but it's just kind of, it's nice that you can do it on the Nectar website. So we're going to open this up, and you're going to see what a TAM looks like. So this is if you remember that little innocuous, sorry, not innocuous Helm chart that we had over here. Wherever it was, it's the Kirby one, whatever, same thing. This is the output from it, and it's it's just a REST interface, and you can call it with release name foo, and then you'll see that changing over here. So it's like templating over API basically, and every Docker image in the world is curl, so we're good. Yep, okay, we're set. So now let's see. Our application is ready. Awesome. So now we're going to open up the client application for Nectar. There is a CLI as well, but we have very high design ambitions, I guess you could say, for the CLI. So we actually ended up just doing it second. Hope you can see this. Yeah. Yeah, so this is the Nectar client application or user application, and we actually already have an old version running. So I'm just going to kind of a sneak preview, I guess. But I'm just going to delete that right now. Deleting applications is really cool because you can just go here. It's actually going to tell you what it's going to kill, what the impact on the cluster is going to be essentially. So you might not want to delete everything, right? And yeah, we're good. So let's go to the App Store. The vision obviously is to be like kind of Steam for Kubernetes. And right now it's an in App Store, but like you'll be able to do this from the web. All the payment stuff, blah, blah, is not there. So I'll just show you the installation. Yeah, so Dice Cream, everything is running. Let's go. So you're going to recognize the permissions that we added before, so people can see and understand what this wizard is going to do, or like what's the worst that could happen. And again, like think conversations with your CIO, like all this stuff matters. Let's go. Moment of truth. Yeah. So it's not installing the application yet. It's installing the wizard, and then the wizard is going to take complete control. Because the wizard, I like to think of the wizard as like, if you could Dockerize a DevOps person, just make them digital, Black Mirror style, and insert them into a company, this is what this thing would be like. Guardrails around everything. Should I apply this? Is this thing ready? Blah 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 blah. And oh, actually, I forgot to just state something really quick. So just the kind of the goals for what are we trying to achieve with this client experience? Control, basically just control. Like, do I feel like I actually own this application, or is it going to screw me over because I forgot to misconfigure something? And how can I achieve this without a significant investment in education? Like reading all the YAMLs and stuff. The README, sorry. Yeah, and second, is my cluster still my cluster, or have I like traded freedom for control, basically? Like, how is my cluster no longer a GKE cluster or whatever? So a minimum impact. And for the vendors, pretty clear. Like you'll see from the SDK, can I do this in a couple days? And can my users get outsized returns in the value they get with the application? So we're checking telemetry over here, like what you're willing to upload and not, because I'll show you that this thing collects data and shares it with vendors, which I think in the long run is good for everybody. Let's go next. Pre-flight checks. All right, so up until this point, this was, this application's code, this front-end application's code, their desktop, that was computing everything. Everything you see from now on is the wizard, which is the thing that the vendors provide. So what is a wizard? What is a wizard, Harry? So a wizard is just, this will look really, really familiar, but it's, this is an entity model kind of thing that you can configure entirely in YAML. And so the things that you just saw over here were predicates, pre-flight predicates. So to recognize all of these, there's a bunch of tools that do similar things, but everything is just kind of integrated over here. And it's a very rich grammar. So you can do things like, instead of passing literals, you can pass in things that compute values on the fly. You can do interpolation. I don't see any over here, but anyways, the point is, as a vendor, you know what kind of the nooks and crannies are in your application, and you can configure this. You basically program, or I hate this expression, but you platform as code it, so that you can actually ship something to the user. So we're going to continue, and then the actual installer is going to start. Now the installer is what we call an operation, and it's just one of many. You can have how many operations you want, but this is just the one that runs when you first install. And over here, I'm going to show you the power of the grammar that we have. So this is, like I said, sometimes it's not a declarative beauty, like you're mixing imperative and declarative things. And there's a bunch of concerns with, like, should I set this variable? Should I not? Blah, blah, blah. So this is the installation workflow is essentially, can I get this person to a state where they have the application deployed securely and to their needs, and they don't have to, as best as we can program it to be, they don't have to kind of translate their demands into finding specific, manifest variables in the README. So it's supposed to be very human friendly. So, you can have drop downs. You can configure different values. And you see it updating on the right over here, because these inputs over here map to manifest variables, which isn't always the case, but you can. It's a common thing. You can have sliders and all kinds of cool inputs and stuff like that. And you can have validations. So depending on the value, so this is constantly pinging the Wiz server over and over and over again. And so it's computing stuff like that. You can have you can generate values, right? So if you're like creating key for a database or something like that, you can. If I reloaded this page, this would be different. But I can just show you what this looks like, because it's really important to understand what what the experience is like for vendors. So this is what generating a password looks like. There you go. So we have. So this is this is our operation. You recognize the pre-flight predicates. We're just referencing them, but you can also embed objects directly. So over here, we have our deployment.password. And it's, so the default value is not a literal. It's it's another kind of object that produces things. So you can, there's a very, very rich like entity model that you can play with. So we're gonna do this. It's gonna get crazier. So, hang in there. Obviously this is a simple ice cream app. There's like nothing complex here. Normally you want to talk about Ingress and you want to do this, you want to do that. But just for the points of, I'm already like 20 minutes in. So let's just plow through. And then, so it's right now what it just did is it pinged that, remember that server that we made, that TAM thing? So it just pinged that. It got, the YAML from it, and it injected all the things in a relevant way. And you can actually have a micro view of your resources over here. Like you can see what's up. You can click on them, get some details. Like just normally, like what I do is I'm on I'm on what's it called, Helm and what's it called, God, K9s, which is like my favorite app in the world. See what's going on. But anyway, let's go. So this is another really cool use case. It's, you know, you're shipping an application, but it has sub-dependencies, right? Like there's something that makes it work better, your application. And you install that for the user, which can be kind of awkward, or do you get them to point to it? And so this is an example. This is actually something that comes standard with Nectar, but this is a Nectar default resource, but the vendor is referencing it. So we're giving the user the chance or the option to create a telemetry database, and they can choose how they do it, right? Like manage PVC, so let me do it for you, basically. Let Nectar do it for you. You can choose your own storage. So it's gonna prompt you for the relevant fields. And again, like I can't emphasize how simple this is. The actual properties and stuff. Yeah, so you can see it all over here. You recognize these values on storage, blah, blah. And for these fields appearing and reappearing, we have show conditions associated with fields. So you can, pretty self-explanatory. Yeah, so we're just gonna use managed. Let's go. And something really cool too is that, for this use case that I just described, like, where do you think the YAML for this should be? Like, should it be in our main application's YAML? Like, I think it's kind of awkward. So you can actually point to other TAMs, other sources of, other templating engines. You just have to specify it in in those YAMLs that we saw, and it'll actually hit another server or another Docker image. And then finally, this is the craziest one. So, like, what application can exist without Prometheus? So other ones aren't supported at the moment, unfortunately. So whoops, let's go back to Prometheus. And then this is really, really cool. So let's say we're going to do it by proxy. We don't have to. We could just, we're running in the cluster, so we don't have to. But check this out. We can dynamically set our inputs to results that we get from querying the cluster. So in this case, this is, what is this, monitoring? Sorry about that, let me make it bigger. So the way that we get the names, it's so simple. It's really just a couple lines. Service namespace, the variable is blah, 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 input. And then, yeah, so this is where we get our options from. Resource supplier, selector, which is Kubernetes, namespace, the kind, and then star. And the way that we do it for the service's name is, it's really cool. So we get the input from the guy above and we stick it right here. See that? So we have our resource selector, and our namespace is going to be the value. So input / the thing that we had before. And yeah, and I'll show you how this all works. Actually, I won't have time. Yeah, and obviously we want to go to monitoring and this guy. So we've now, this is like the whole point of this is you install things in such a way that it's really hard to F up, which is, what you want if you're like selling software to somebody for several $1,000s. And so monitoring, blah, blah. And then we're done. So we've installed the application. And then this is so no sexy graphs, unfortunately, because but so everything you see on this page is vendor defined, essentially. Like the front end is doing very little work. All of this, almost all of this, is defined by the vendor. So we can click on the home page, which I found. So this is it. So we've successfully deployed a thing. I find it weird that you can deploy applications with Helm and not even know where they are. You have abstractions for database, things like that. Again, this is all with the YAMLs. You can 1 minute left. God. You have an index of your manifest variables, descriptions, all of that. You can filter. You can click on them, set them again. If you're crazy, you can get rid of the lock. Set whatever you want. But it's not recommended to do that. Once you do that, you get the option to commit. you have our operations. So this is, think about anything related to like databases or maintenance or, registering with an API. So vendors can just define these operation things in YAML, and, arbitrary sequences of steps and staged stuff and actions. Oh man, we won't have time to show you the updates, but you can update really safely. Actually, let me just try. So creating an update in Nectar just works like this. Normally, again, you do it, GitOps way, but let's just try to do it here. I even have a really cool release note that I stole. Let's have it over here. So manifest release 101. And then if we do this again, we have it over here. And actually before that, we can take a backup what things are like right now. So we call it safe. And this is going to save the entire state of, like all my manifest variables and all my preferences and stuff like that. And so we feel safe before we update, which we'll do right now. As I'm showing this, I'm just multitasking. I'll talk to you about probably the coolest feature I didn't get to show is fault tolerance. So, debugging your application is one thing, but a stranger's application, totally different ballgame. So yeah, there you go, worked. And we can run a system check. So these are just predicates. This is something that the vendor defines. And they just check a bunch of things about your cluster. By the way, Cheryl, you can interrupt me at any point. I realize that I'm way over time. Yeah, and so sorry?
Yeah, it's all good. Maybe
okay.
A couple of minutes more.
Okay, sure, thanks. Yeah, so these are a bunch of pre-flight checks, sorry, not pre-flight checks, but system checks that you can run at any time if you feel like, there's something wrong with the application. Again, all vendor defined. So this is the diagnose button. Right now it's not working, but I promise it's, normally it does. And again, like you define error handlers, everything in the YAML. Yeah, and I showed you deletion already. And so the very, very last thing that'll show is what it actually, just 2 seconds, what it looks like to actually develop an application with this exact same process. It's this is made for developer or vendor happiness. So you choose your namespace, and you can actually choose a local executable for both the wizard and the TAM, or a local server rather. Yeah, and all it takes is, you're developing, and all it takes is a server reload, which Flask does automatically anyways, and you see the application changed. So yeah, we're just looking for people who are excited about this kind of thing. Start using the SDK. So if you or anybody else is interested, just drop me a line at write it here, Xavier at codenectar.com. The documentation online is kind of half-assed right now, but should be ready by Friday. So if you go to docs.codenectar.com, that'll be there, and it's entire documentation for the Wiz and everything I just spoke about, like TAMs and stuff. Okay.
Awesome. Yeah, thank you so much, Xavier. This is super interesting, and I also love it when speakers don't do slides and just talk. So that was awesome. Thank you so much.
Thank you for having me.
We're unfortunately out of time for questions, but again, people can get in touch with you at that email, right? So we're going to just take a 15-minute break now. If it's okay, I'm going to ask you to stop sharing your screen so we can play a little bit of music and
yeah,
hang out with other people on the Rambly. All right, folks, we'll be back in 15 minutes. Take a break, stretch your legs. You can go to this link and chat to some of our other attendees if you want as well. Hi, folks. Welcome back. Hope you had a little bit of a break and a chance to refresh yourself a little bit. I'd like to welcome now Peter, who is our third speaker for the evening. So Peter, over to you.
Thank you. Let me just make the technology work. Not that button. Right. So thanks very much for staying this long in the evening. This talk is going to be a bit different. I'm Peter Parkanyi, and I work at Sift. You can find me on Twitter and through email. I'm mostly involved with Rust, security, and the Linux eBPF community. And eBPF is also the sort of very exciting technology that powers Ingress, which is the little logo at the bottom of the slides that you can see. And the CNCF Falco project as well, if you're familiar with that angle. What I want to talk about today is that a lot of people that we're talking to when we start discussions is that they are trying to move to the cloud, but they are not entirely sure how, or there are pretty big obstacles that actually block them from doing so. So the thing is that actually moving to the cloud is not necessarily a straight line. There's some exploration involved, and I just want to go through the different considerations pretty much along the survey that we were looking at the beginning of the meetup. One thing to consider is there's no right approach. There's always a right approach probably for a company, but there's no universally accepted, this is the way you do it. And I think a lot of the tooling that's out there actually helps you get the really difficult bits out of the way, so you can focus on actually figuring out how things can work for you. What I'd like to consider in this context is we actually have to look at a number of things when moving to the cloud. We have to look at our people, we have to look at our process and our platforms. And really, I think the process is the thing that pulls this entire thing together. Obviously, there are a lot more considerations like cost and benefits, but it really boils down when you've unlocked those is to for a successful transition from an on-premise environment or expanding your cloud from one cloud to multiple ones is nailing these three items. So get used to triplets. There are going to be a couple of these in the presentation. One thing that you should really consider is that transitioning actually takes time. You shouldn't think about it as a one-shot project. You should think about it as kind of transitioning into the mindset of building for the cloud. And with that mindset, you can successfully expand your deployment or expand your environment and gradually probably let go of all the components that don't serve you anymore. If you think about Marie Kondo, just get rid of the stuff that doesn't bring you joy. But it's not necessarily a weekend. It's probably going to take a while. So let's kick off with people. The problem with people is that habits die hard. It's really difficult to once you have an established process of how you deploy things and how you do your development. It's really difficult to change that from one day to the other. And actually changing corporate strategy or organization strategy means that you have to change the habits of the people who are working on that system and who are working in that environment. Do you remember what life was before Docker, for instance, because I don't really. It just became an essential part of my workflow. And even if I'm not necessarily deploying something at scale, there are unique benefits that Docker adds to the workflow. But for a quick reality check, many developers haven't ever used Docker. For a lot of niches, specifically, for instance, front-end developers who don't necessarily interact with this world, Docker is not necessarily a thing. And the same way for a lot of organizations, figuring out how to Dockerize things and how to actually think about containers and the sort of deployment checklists is actually really, really challenging. So another triplet for you to remember, a really solid approach to go about this is you have to survey what people think about the current process, what people dislike about the current process, most importantly, what is it that they struggle with the most, and try to improve on these ideas and on these processes. And then once you've identified the sort of key challenges and the next steps, you can iterate on it. Again, think about it as a process. It's not one thing, and you won't solve all the problems in your checklist with one sprint. It's going to take a couple of sprints to build up and iterate on where you're going and how you're approaching things. One very important thing to consider is that as the complexity goes up of a deployment or an environment, the cognitive load increases exponentially. I really, really dislike having to think about what could possibly go wrong in a certain scenario when I'm deploying something, because I don't remember all the little nits and jiggles of what's going on in any particular scenario. And you can bet that most people will actually struggle remembering this even 90% of the time. This problem becomes even more hard when you don't deal with these systems day to day. And I think there are many people whose workflows don't depend on continuous deployment, even if they are part of an organization whose workflow as a whole does. And for them, saying just deploy something to Kubernetes could be actually prohibitively difficult at some point in time. Developer tools are user interfaces, and whether you're thinking about the command line tools like kube control or some sort of online dashboard thingy, or you think about your monitoring interfaces, they are user interfaces that you're using to get work done. And it's very important that you consider that these tools are actually usable for people who are working on them. Don't be afraid to create custom tooling, but if you do that, you have to keep abstractions thin, which means don't try to abstract away everything. I think it's really helpful if you keep your tooling very close to the original one, and just keep the smallest possible layer that is custom to your organization, while trying to make things as uniform as possible. I know these are kind of opposing ideas, but I think there's an important balance to strike there. One of the most important aspects, though, is that mistakes should be impossible by the tooling. This is something actually that kube control doesn't provide you. You can make mistakes. It's really easy to make mistakes. It doesn't defend you against yourself. The kube control abstractions, however, for instance, they are very thin. You're basically directly interacting with the system. As long as you're understanding the system, you know what you're doing. The interfaces are super uniform. You know precisely how command structures look like, where you can pass options, and so on and so forth. But it will not defend you against yourself. And I see a lot of startups in the industry actually trying to solve this crucial problem. One of the ways to actually stop yourself from making mistakes is paying attention to the process that you use to deploy. I found this chart on Twitter and I really, really liked it. And it's applicable to so many things. Obviously, Happy Automata tweets without context, and actually this is an AI that generates pictures. But this is sort of the ideal DevOps workflow for many people. The first step, you send something to the CI and it works, and then you can deploy that immediately to production, and everybody's happy. You gain stars, but every once in a while you get that little bit of fire. And it looks like emojis don't work when you maximize this presentation, but the goal is to maximize the stars and minimize the fires that you're fighting. And those fires come from several different places. Things may not work as you intend them to. Things will break as a result of the deployment, and things get hacked. It's basically a matter of fact. If your exposure is big enough, or if your systems are unsecure enough, you will get hit. And so it is sort of a scale of panic that we're talking about here. When things don't work, they might not actually impact a lot of things. When working things break, you have some reason to panic. And when things get owned, then basically the house is burning. And you need to act swiftly and deliberately and very confidently at that. So one solution to this problem has been to kind of combine DevOps and security into one single process and incorporate it into your day-to-day workflow. DevSecOps is a bit of a loose buzzword, I feel. A lot of DevOps advocates say that DevSecOps is basically DevOps. It's just a new buzzword that you're trying to extract. But if you look around in the real world, and certainly from my experience, I think a lot of companies for their existing environments started adopting DevOps workflows. They are somewhere in the process of actually maturing those DevOps workflows, but their security is still handled by different teams. Which means that security reviews of deployments and security reviews of the containers that you're building and a bunch of other things are not necessarily essential part of the process. And it's fair enough because it takes time to build these things up. So really an ideal place where we want to get to is having end-to-end automation for the tests. Having end-to-end automation for keeping dependencies up to date, for ensuring container integrity, scanning containers for known vulnerabilities, for the artifacts that the CI generates. We have to scan them for malicious dependencies, for instance, which is a pretty real threat, and very often, typically in the Node ecosystem. Which is notoriously vulnerable, I guess, probably because of its scale to these types of attacks. You can introduce new dependencies that from one day to the other introduce deliberate vulnerabilities that will be exploited. The other thing that we have to consider here is policies. Once you're in the cloud, and once you're using Kubernetes or one of the big 3 cloud providers, you get very powerful tools for constraining your policies. But these policies don't always work for every use case. So you're kind of in the balance of, well, I want policies to protect me as much as possible, but I'm probably not there yet. And that's fine. The crucial thing is that you have something to fall back on for security, even if your policies don't necessarily think network policies, think IAM. They might not be necessarily there yet, but you should have another monitoring layer and security layer to fall back on in order to ensure your security. And I'm kind of paraphrasing Lenin here, who said, learn, learn, learn. Well, I'm saying monitor, monitor, monitor. When you think about including security as part of your process, you really need to put a lot of effort into sophisticated monitoring. And based on the previous slide, you want to monitor configuration changes to your cloud environment. You want to monitor access to your cloud environment. Think about your users. Think about when they SSH into production systems, whether they can SSH into production systems, and how they are modifying configuration. And on top of that, you also need to consider that you need to monitor what your services are actually doing runtime. This is a key piece of information that that is really difficult to get right. And most companies, most projects try to get away with application performance monitoring in this sphere to figure out what applications self-report. It's not really good enough. If your goal is actually ensuring any sort of security, then self-reported stats are just not enough. So in order to get the process in place for DevSecOps, you really need to set up a reasonable schedule to automate as much as possible. And you need to focus on gathering the right evidence and the right amount of evidence. A lot of people approach this as, oh, we'll just gather everything and then see what's intelligible from it. But you really don't want to gather more than you can chew, because you're just making your own job more difficult. And all of this evidence gathering and all of this automation helps you actually get to the point where making mistakes is impossible, where making configuration changes that accidentally open up an unsecured MongoDB instance is impossible, where your pager duty goes off the second that happens, where accidentally pushing out broken features is impossible, where accidentally deploying dependencies that carry known vulnerabilities is impossible. Obviously, there are lots of things that are going to slip in. And this is where the platforms get interesting. A lot of platforms now provide built-in monitoring systems and a lot of built-in intelligence to give you all of this information so that you can move forward with confidence, some sort of confidence. But a lot of problems are really best served by external tools. So a lot of people focus on procuring and finding the right tools over finding the right approach. And I'm here promoting a tool that is going to give you a lot of evidence. So I'm kind of speaking against myself, but then again, you kind of need to incorporate this into your strategy, because moving between clouds requires solid tooling. Expanding the scope of your cloud deployments requires really solid tooling, because you're expanding your complexity and expanding the cognitive load that your system now inherently puts on your developers and puts on your operations teams. So really, we have to go back to our triplet. You need to survey, you need to improve, and then you need to iterate. And in this case, you're not surveying developer happiness. You're not surveying developer attitude. You're surveying how your systems work. And then you're trying to improve how they work gradually and deliberately based on the evidence that you're gathering. If you're focusing on security, then obviously a layered approach is best, as I mentioned previously. So what we see a lot of companies move to, who are relatively mature in their cloud adoption, is a two-layered approach, where cloud security posture management basically processes your logs, audits your cloud security configuration, and monitors all of this real time. It will give you the alerts that you want for configuration changes. It will give you the sort of insight into access logs and how your people use your cloud and how your people use your systems in order to achieve their goals. And on top of this, they, as a fallback layer and as a much richer source of intelligence, they are relying on runtime security observability to gather that evidence that that you do not get from logs, that you do not get from cloud configuration audits. Runtime monitoring really gives you the best visibility that you can get, but you really need to put it in perspective where that visibility can be used by your teams to improve your process and to actually incorporate that evidence into improving your process and improving your security. What Ingrain provides you is a very fine-grained detail of what's running where, regardless of what cloud provider you're using, whether it's on-premise or in the cloud, whether it's an outdated systems that you're migrating away from, to whether it is your cutting edge fancy piece of tech that you build on a Kubernetes stack. So what you can see here is really end-to-end. You're seeing the IP addresses and the services that are involved, all the files that they touch, and all the systems that are involved in the computers that are involved in this process. And I don't really know, and I don't really care where those systems are, because from the perspective of security, we really see no boundaries today. And the perimeter-based security approach is no longer really serving you. So getting a tool that will give you the utmost visibility to start off your process will give you the confidence to actually start building on realistic security boundaries that are not necessarily tied to this cloud or the other. And yes, you have to monitor. This is the only way you're going to get enough information to actually serve you in a successful cloud transition. You really want to establish a single source of truth for all this evidence that you're gathering. And this single source of truth, as I said, must be opaque to which cloud or which on-premise or which data center. You really want to look at the abstract view that is kind of detached from this, because that's the only way you're going to be able to make reasonable decisions. And this kind of evidence that you're gathering with runtime and with posture management, security approaches gives you a principled design approach for improving your systems and improving your processes that you use to build those systems. Using this evidence, you can make mistakes more difficult. Mistakes are never inevitable. Obviously, we're kind of trying to converge into the place where we cannot possibly make them. But nothing is going to stop you rolling out a zero-day vulnerability because nobody knows about a zero-day vulnerability. And this is where runtime security will help you out very, very much. You will be able to pick up zero-day vulnerabilities and very early signs of compromise that nothing else can catch. And that's a mistake that you've made inevitably and indefendably, but you will be able to react quickly. And really, this is the point. Evidence allows you to iterate and respond with confidence and with speed. So really, the point is that a successful cloud transitions starts with your people, and your platforms, and the way that you use your platforms should be your last consideration. They offer comparable features across the board, but it's really going to be your process, your approach, and the tools that you provide to your teams that are going to help you make this successful. You don't always have to just focus on the latest tool and the latest gadget. There's a long way that you can go choosing the right approaches and the right mindset in order to move from one place to a better one. This is really what I have today, and I'm happy to take some questions. And I'm going to need some help to figure out how that happens. And if you have any questions or feedback, or you would like to take Ingrain for a spin, feel free to reach out to me either on Twitter or through email, and we're happy to give you a private demo and take a look at how we can help you with your current problems.
Fabulous. Thank you so much, Peter. This was really fantastic, and I really enjoyed it. So I want to say thank you for sharing this with us. If you can turn off your share screen for a moment, I would like to share mine. And then if people have questions for Peter, we only have about 3 minutes left, but you can go to this link and just pop them into here, and then we'll see if any come up and Peter can answer any questions. Give a few moments.
The suspense is exciting.
I love it. No, it's all good. I think we are pretty much out of time, actually. So
Okay,
yeah,
well,
but Peter, you already shared your Twitter and your email, so people can always get in touch with you there, right?
yeah, absolutely. Thanks very much for having me, and thanks for pulling this together.
Yeah, very happy to. And thank you, everybody, for joining us across YouTube and Twitch and Rambly and everywhere else. And I just want to say again, huge thank you to Denis, Xavier, and Peter for sharing everything that they've done with us today and for the talks. We are going to be back again at the beginning of January, the first Wednesday of January. And yeah, that's it from us. So have a great evening, and we'll see you again next time. And have a fantastic Christmas and a Happy New Year. Thank you so much.
Thank you.
Bye-bye.